has yeah, he's here for about 15 or 20 minutes, and he can't attend more of that live session. Some other time slot, and he suggests post 10 p.m. is usually best for him, but 10 a.m. to 12 noon. I mean, we would love to accommodate alternative time slots, and try and work with everybody's schedule as much as possible. Um, but beyond 10 p.m. it gets a little late, and a lot of us are actually teaching during the day in our respective institutions. So during the workday between 9 o'clock and 5 o'clock also tends to become a little difficult because we're actually in class teaching people, and so it might be difficult to do that. But I'll speak to Amrita uh, about potential um, changes in timings, and we can see what we can do about that. Um, oh, someone from the US. Oh, well, welcome. We've got an international audience then. Yes, but I mean, US timings and India timings are always going to clash. I have another couple of things in the spreadsheet that I'm just going to get to, which is um, Shahbaz asks, what is the reason of vulture extinction? Vanished from Kolkata Victoria Memorial Ground. I mean, vulture extinction has happened across the country, and we'll get to why that has happened when we talk about bird conservation. But the short answer is vulture extinctions have happened because of a veterinary drug called diclofenac, and diclofenac is basically given to cattle and when they're ill, and cattle die, and when the vultures feed on it, diclofenac is actually a toxin. But we'll get into that in more detail when we talk about conservation. I have one more species here from Ram, which is our endemic species to be considered as specialists. Not necessarily. Often endemism is a phenomenon of islands. Uh, So I suppose you could say that island specialists in some sense, but a lot of endemic species could also be generalists in terms of what they're eating, in terms of the habitats that they're found in. When we get to biogeography and macroecology, and we actually look at the causes for endemism, which could be historical causes with changes in climate, changes in weather patterns, changes in vegetation, and how vegetation has covered the earth. We will get into endemism. So that's coming in a subsequent. Uh, uh, Mr. D'Souza. Oh, I see. Okay, one. Oh, I see. Okay, here's the question that Mr. D'Souza is asking, which is in the bird communities lectures give us a number of graphs resulting from some truly thought-provoking innovative experiments. Um, Concepts Part 2, discussing predation and bird communities. You have three graphs based on results after removing predators from certain habitats. Thus, we know the effect of such removal of these predators on singing rate, breeding density, and daily nest predation. But the last of those three puzzles me. If you remove predators, seems to be obvious that nest predation will decrease. Why is that measured at all? Sure. Often what happens in a number of cases in ecology when we're doing studies in the field, and we're manipulating things, for example removing predators from a particular habitat, um, you might expect certain obvious things to happen, and definitely by removing predators you would imagine that one of the obvious things that's definitely going to happen is that nest predation rates are going to decrease, or nest losses are going to come down. However, in a community of nesting birds, let's say predation is not a particularly important factor in structuring bird communities. Let's say competition is more important, and it's actually competing individuals that are going and destroying each other's nests, then the removal of predators would not have as much of an effect on nest losses than the removal of competitors would have. So it's one reason to sort of rule out the possibility that other things are affecting this particular phenomenon more strongly than predation. Uh, so that's the reason why that's been measured.
Okay,
One of
thanks.
the reasons why that's been
Thanks.
measured.
That makes it clear. But thanks a lot. And thank you for taking it up before I leave. I really have to go, but I really appreciate it. Thank you.
Oh, not at all. You're more than welcome. Thank you for joining for as long as you could.
Okay, thank you. Bye bye.
Bye. All right. Now we've got a few questions here in the live session document. So the questions for Mousumi, which I will be taking up, this is from Population Ecology, which is the definition of the term region when somebody says that population is a set of individuals in the same region at a particular time. Then what you're talking about is what's called geographical closure, which is the number of individuals in that region. But that region um, could be uh, like this person points out. Unfortunately, I don't have the name here, but this person says, based on the same in my understanding, the region here can be anything like a park or city locality or a district or a forest reserve. Yes, it could be any one of those. You would be talking about populations at different scales. You would be saying the population of birds in this park is 20 individuals. In the city locality, it's 400 individuals. In the district, it might be a million individuals. In the forest reserve, it might be 2 million individuals. So you're basically talking about the geographical scale. You're changing the geographical scale at which you're measuring how many individuals are there. Uh, and the question continues, which is the same has been discussed in the concept of geographical closure. However, this concept holds for wintering and non-breeding season also. It does. So we do talk about breeding populations and wintering populations. Many bird species breed in certain locations, and then for the winter they actually move to a different location. And so then we would be talking about breeding populations, and you can say breeding population in a park, breeding population in a locality, or you could say wintering populations in a reserve or in a district. So that would hold for wintering and breeding populations as well. A large number of bird species actually don't migrate their residents. So the winter and the breeding populations, in terms of scale, in terms of geographical region, when you say winter population, summer population, you would be referring to the same region, not different regions, unlike for migrants. Um, so there's a question on population growth rate. Sorry, on survival rate, and the there is that notation that's used often to talk about annual survival, which is you use um, mathematical notation. You would say n sub t for population size at time t, n sub t plus 1 for population size at the next time step. But if you actually had to not use that mathematical location and look at it through a simple example, then if you have, let's say in 2011, you have a population of birds, and that population is 100, and then you have 7 birds dying between 2011 and 2012, then over that annual time period, what's happened is you've got 7 birds that have died, right? Uh, and so the number of birds that have survived from that initial population are 93. Yes. Now, when we're talking about survival rates, we're just interested in what proportion or percentage of birds have died from one time step to the next, and the remainder are the birds that have survived. We're not really interested in birds that are either coming into the population from elsewhere, born somewhere else and coming in, or birds that have moved out of the population because they've actually moved out. They've survived, but they're not in the population. So when we're talking about annual survival rates, if you've got 100 birds to start off with, and 7 die, then annual survival rate would be 100 minus 7, 93, divided by 100, which is 93% or 0.93. So you could make a statement like annual survival for this population of house sparrow from 2011 to 2012 was 93%, or 0.93. So that's the way in which the survival rates are calculated. Just go back to that document. Um, is it possible? This is about sources and sinks. Sources are populations that have generally that create more individuals than they can support in the long term, and so those sources actually contribute individuals to other populations. So individuals move from source populations to other populations. Some of these populations can be sinks, which is if these sinks do not get individuals from source populations, in the absence of that movement from a source population into the sink population, then the sink population is not able to maintain that population. It relies on immigration, it relies on the movement of individuals from sources to continue to persist. In the absence of that movement, in the absence of contribution of individuals from another population, sinks will ultimately decline to extinction. And the question here is, could it be that in the example that Mousumi showed, the sink might just have transitions uh, tea plantations in the Western Ghats, and you've got patches of forest within the Western Ghats. Within these tea plantations. And the tea plantations might be very good for birds to move through from one rainforest patch to another, but they're not very good for birds to settle in and breed and produce offspring because there might not be enough resources, and so on. So the tea plantations might be acting as a transition zone for birds moving from sources to sources. When a bird might move from a source to another source, what might happen might depend on the body condition of the bird. So if this bird moves and reaches another location where there are already individuals there, then if it is a superior competitor, it might be able to take over a territory. If it reaches there, but its actually body condition is not very great, the resident birds in that patch are already of good body condition, they're higher fitness, then this new individual might not be able to colonize, might not be able to establish a territory in the other source. Um,
Yeah, yeah. Hi, Umesh. I think there is no name mentioned in the question, so I couldn't able to. If the person is here, I think is this Mayank, and ask this question. If you need any clarifications, you can unmute and follow up, or is that okay?
Great, thank you. Thanks, Samruta. If you need any clarifications about what I just said, please do type that into either type it into the chat box, or let's just finish off with the other
Sure, sure.
questions that are.
Yeah, sure. Yeah, that will do.
All right, questions on community ecology. This is about the experiment between experiment excluding great and blue tits from nest boxes, and where you exclude great and blue tits from nest boxes, the fitness of the competitor species, which is the collared flycatcher, actually goes up, right? And so it is an experimental thing. You are excluding um, a competing set of species. You're not excluding them from the habitat. What you're doing is you're excluding them from the nest box. So they could be in the forest. They could be there in the forest. And the resource that they're competing for, the collared flycatcher and the tits, the resource that they're competing for is the nest boxes. And the tits want really deep nest boxes, but if you raise the floor of the nest box, if you put a block of wood at the bottom of the nest box, the tits will not nest in those nest boxes. And so they will be excluded from the nest boxes. So that's the way in which the exclusion has been done That's the way the removal of the competitor has been done. It's by making sure that they do not or are incapable of occupying the nest boxes that are already in that habitat. So someone asks if we can provide an example of density inflation. Um, I forget the exact species that this is, but um, these are islands of the east coast of South America, where you've got on the mainland in South America, you've got multiple species of, I think it's an ant shrike. You've got multiple species of this ant shrike genus. Under the island, you actually have only one species of the ant shrike genus. And where on the mainland, you've got multiple species of ant shrike genera, the population size of each of those is low. And you've got this, and then you've got this one ant shrike species on the island where it's not competing with other ant-shrike species because they're not present, and then the population size, the population densities, and that's population size per unit area of those island ant-shrikes is actually higher than you see on the mainland. So that's um, an example of um, a density inflation since competitors. Yeah, there's a question about that very interesting experiment about replacement zones, where you have in the Andes, you have two species of wood wrens, one occupying a lower elevation, one occupying a higher elevation, and then you've got the replacement zone in the middle where species A stops and species B begins. So species B is found higher up, species A is found lower down. And species A does not respond to the song of species B away from the replacement zone. Species B does not respond aggressively to the song of species A away from the replacement zone, but A will respond aggressively to B at the replacement zone. B will respond aggressively to the song of A at the replacement zone. And this, I think, this is Ram who actually downloaded the songs from this. He asks, and he's made some observations of different the songs could be for these different species. Um, and the songs actually sound to us quite dissimilar. Uh, so the question is, if those songs do sound very dissimilar, why would one species react aggressively to the song of the other? Right? It should definitely react aggressively if it's a territorial species to the song of its own species, which is more similar to its own song than the song of another species, which is more dissimilar than its own song. And yes, to us, those songs might sound quite dissimilar. There are examples of where I work where two songs sound very, very similar to each other to our ears. And some of these are, if you're interested, look up species like the golden babbler, um, the rufous cap babbler, and the rufous fronted babbler. It's a set of species that all belong to the same genus, and those songs sound very similar to us. But these birds are not actually responding to each other across species. So even though songs sound very similar to us, um, they might sound very different to other species. They might be picking up on things that we are not picking up in terms of differences between these songs. The other reason I can think of why there would be that aggressive response in the replacement zone is that over evolutionary time, if species A does not respond aggressively to the song of species B, then its territory is going to get taken over by an individual of species B. But, sorry, Rahul, uh, and so It could be a learned behavior where species A, the population of species A learns over time that not responding aggressively to the song of species B actually means reduced fitness, actually means that your um, territories are going to just get taken over. So even though the songs might sound very different, there might be aggressive responses to these different sounding songs. There's a question of niche overlap. We have earlier studied that no two species can occupy the same niche. Is it possible for two species to have 100% niche overlap? This is coming from the concept of competitive exclusion, or Gauss's law, which was formulated in 1934. And Gauss actually states that the actual statement is complete competitors cannot coexist. And people have criticized the theory of competitive exclusions and also tried experiments with beetles and so on, and shown that in those specific instances it actually does not work. There is no evidence for competitive exclusion. In reality, out there in the field, showing competitive exclusion is very, very difficult. What happens is, if you have two species that look very, very similar to us, and they're found in two different islands, for example, then one would say, oh, look, species A is outcompeting species B on island 1, and species B is outcompeting species A on island 2. And here's examples of competitive exclusion where A is excluding B and B is excluding A. And then we would say, yes, look, competitive exclusion works. However, if to us we find two species that are very, very similar to each other, and both of them are coexisting in the same habitat, both of them are actually there together in the same habitat, then one would say, it's often said that, oh, you know what? There's no way that these two species can actually be sharing the exact niche because they're coexisting. So there's something that we've not measured, some important difference between these species that we've not measured, that's actually allowing them to partition resource use and being able to coexist. So it's very difficult to either confirm or deny competitive exclusion, especially in the wild. So, it's a very, very influential theory in competition. It's a very, very influential theory in ecology. But what usually happens is, especially along, let's say, an elevational gradient, two very similar species will diverge. One will become, let's say, a high elevation specialist. The other will be a low elevation specialist. So they actually do sort of exclude each other, like that replacement zone example. The low elevation species might exclude the other, the high elevation species. The high elevation species might prevent the low elevation species from entering the high elevations. So they might be excluding each other along that elevational gradient, but at the scale of the mountain, they do coexist. They're there. Both of them are there on the same mountain, but they're partitioning space in terms of elevation. So it also depends on the scale at which you look at this. To just it's silly logical extreme, right? So the scale also matters. What scale are we talking about when we're talking about things like competitive exclusion? So this question on interference competition, and we say that this example given in interference competition is extension of the concept of the realized niche. So the realized niche comes about, one of the definitions of the realized niche comes about as the result of competitive interactions. So let's say you are dealing with a bird species that can occupy all of tropical evergreen forest, and that's its fundamental niche. It can occupy all of tropical evergreen forest. But there might be another species that is in interference competition with this species in a particular part of tropical rainforest, tropical evergreen forest, then that competitor species might prevent the first species from being present in that location. And so, just in terms of geographical space, the fundamental niche of that species might be, you know, the entire Western Ghats. But in the southern portion of the Western Ghats, there might be a competitor that prevents it from occupying because of interference competition. And that interference competition then leads that species to being restricted to the northern Western Ghats. And that then becomes its realized niche. Fundamentally, it can occupy the entire Western Ghats. In reality, it can occupy only the northern Western Ghats. So if you remove the competitor, you can actually potentially have that northern Western Ghats species um, occupying the entire Western Ghats. That's the concept here. Uh,
Umesh, may I clarify the question, please?
sure.
Yeah, basically, it was related to the example you had given in the lecture on interference. So, the example was about the tits occupying the inner portions of the conifer trees and other ones occupying the outer portions. And when the species
Right.
occupying the inner portions were removed, so the other species could utilize the inner portion also for feeding. So it was regarding this example. I just wanted to clarify for my understanding that what I have understood with the realized niche, is it the correct concept? Thank you.
Got it. Got it. Sure. So in that example, you have species feeding on the inner parts of the trees, and you have species feeding on the outer part of those trees. And I can't recall exactly what, but I think if you remove the species that are on the inner parts of the trees, then the species that were restricted to only feeding on the outer parts are able to feed on the inner parts of the trees as well. So the fundamental niche of that second species that is feeding only on the outside in the presence of its competitor, the fundamental niche of that species actually also includes the inner part of the tree. But because this competitor is aggressively excluding the second species from the part of the tree that's close to the trunk, the realized niche as an outcome of interference competition becomes the outer part of the tree. Is that answering your question, Mayank?
Yeah, definitely, definitely. Yeah,
All right.
thank you.
Okay. Thanks. And then there's one last thing here in this document, which is the example in on apparent competition. Can we take the example given in apparent lateral competition as also as an example of bottom-up effects? Um, Apparent competition works through a combination. Yes, it works through a combination of top-down and bottom-up effects, right? You've got the bottom-up effect, which is you've got two competitors, and those two competitors are being predated upon by a predator. Both of them have the same predator. And so there is a bottom-up effect here where there's prey feeding predators, right? So you're going from the lower trophic level to a higher trophic level. So there's a bottom-up effect happening there. But there's also a top-down effect, right? Which is if you increase the abundance of the competitor species A, you're also increasing the abundance of the predator, which then also has a top-down effect on competitor species B. So it's a combination of both bottom-up and top-down effects when it comes to apparent competition. Um, yeah, when we yes, so yeah, it's competition mediated through bottom-up and top-down effects. So I think there are a couple of questions in the spreadsheet that I'll just get to, and then we can look uh, in the chat box for what's typed in there. So there's a question for Mousumi, which is I understand how generation length is calculated from life tables. Again, we're back in population ecology. What does that number mean? Definition? How is it used in the real world? So that number means what is the average difference in the age of two generations? So, we all know that human generations are classified, right? Baby boomers, Gen Z, Gen X, and so on, millennials, whatever it. So the average age difference between a millennial and a Gen Z would be, 25 to 30 years, and that's generation length, that's generation time. It's the time taken for, um, what is the time interval between an individual being born and then an individual reproducing itself. That's generation time. Yeah, so that's the technical definition of generation time. It is the time from birth to the average age at reproduction. And that's what gives us our generation timings as well. The second part of this is, um, what is the difference between generation length and life expectancy? Life expectancy is what is the average age that you can expect an individual to live to, um, in a population, right? So, if sort of like average lifespan, right? So, for a small bird, life expectancy might be 2 years. For an albatross, life expectancy might be 80 years. So it's, once you're born, how long could you expect to live? How long does the average individual in a population live for? That's life expectancy. I think we've done with those questions in the spreadsheet. Let's look at the chat box here. So Vijay has a comment or a question, which is based on the lectures on community ecology. I understand that efforts to conserve and restore needs to be holistic, bring back the undisturbed condition. Your advice as to how to go about with it. I live in Jamshedpur, Jharkhand state, with two rivers and Dharma Wildlife Reserve. I think I got dropped over there. Am I back? Can you hear me?
Yeah, we can hear you. Now
Okay,
we
thank
can.
you. Right, I'm just going back to the chat box. Sorry. Yeah. Um, so how to bring back the undisturbed condition? It depends from ecosystem to ecosystem. It depends on the level of disturbance. So, for example, if you there's a recent paper last year on logging, which is cutting of timber from rainforests, and it turns out that if you cut 30% of the timber in a forest, and if you just leave it the way it is, then it will come back to what mature, undisturbed forest looks like over time. But if you cut 70% of the forest, you might have to actually go in there actively, plant saplings, plant trees to be able to bring back what it originally looked like. And if you don't do that, then that forest is never going to recover. That ecological community is never going to come back. When we talk about conservation and especially restoration ecology, we will touch upon these things, but it differs from place to place, ecosystem to ecosystem, habitat to habitat, species to species, whether and the level of disturbance. Some species are capable of dealing with a little bit of disturbance, with a lot of disturbance. For some species, even tiny amount of disturbance means they're not going to be able to handle that, and they will disappear from that disturbed habitat. So it depends on a number of factors to be able to bring back um, um, that entire community. I'm sorry, I know this is not a satisfactory answer, because basically the answer is it depends, but it is the answer. It does depend on a whole variety of factors. Dr. Hariom Verma says we can use stepwise regression to estimate the impact of different drugs. Yes, absolutely, we can use stepwise regression to estimate the impact of different factors on populations. Another way to do it is perhaps use multiple regressions to influence to understand how various factors are influencing population size or population growth or so on. So Alberto Ramamurthy, uh, he says, I did an experiment in my backyard yesterday, a northern cardinal, which is a species, largish red finch-like bird, actually responded to the speaker when I was playing the house finch. Fascinating, which is fascinating. And that comes back to our replacement zone example, where even though the songs of those two different species were very different, one species was responding to the song of another species, and one could imagine that house finch and cardinal might be actually competing for the same resources. They look very similar. Their bill, their beaks are very, very similar. They're probably eating very similar things, and yeah, it's a fascinating thing, and um, so it could very well be that both of them are actually competing for the same resources, and you will see this kind of response between species that actually don't sound very similar to each other. In a variety of cases where species might recognize that the presence of another species, recognize over evolutionary time that the call of another species is is going to affect, not consciously, but that over time, that the call of a species is likely to result in reduced fitness. So thank you for that, Mr. Ramamurthy. So I think we're done with the comments in the spreadsheet and the document and what's in the chat. But if anyone wants to add any comments or suggestions, or wants to follow up on any of the questions that were asked or requires some more clarification, glad to do that.
Yeah. I think there is one more question, stress gradient hypothesis, right? Jay, from Jay, in the
Where is that?
in the chat.
Oh,
So
I don't see that here. Can you post that again,
I
please?
can.
Yeah, thank you.
So about the stress gradient hypothesis, you mentioned that during resource scarcity, we mixed that we see mixed species flocking, while when there are ample resources in monsoon, then we see more competition. What is the reason for this behavior?
Yeah, can you just paste that into the chat box, please? My
Yeah,
connection
sure.
is dropping.
Yeah,
Yeah.
I can. Is it visible now?
Yes, thank you. About the
Yes.
stress gradient hypothesis, during resource scarcity, we see mixed species flocking while there are ample resources. In the monsoon, we see more competition. What is the reason for this behavior? So, we might not actually be seeing more competition in the monsoon, although the stress gradient hypothesis does state that resources become scarce, interactions tend to move towards facilitation. Um, when resources are very, very common, there might not actually be very strong competition, but it could be. So here's one hypothesis, and there are many potential explanations for this. But here's one that comes immediately to mind. When resources are abundant, you don't need to spend too much time looking for them, right? If there are insects on every leaf, then you're not spending much time looking for insects, right? You have enough time to invest in actually looking out for predators, because you can feed for a short time and you'll get the energy that you need. So you're actually able to look out for predators, and spend that time to avoid being killed or avoid being injured by predator. When resources are low, then you need to spend a lot of time looking for those resources. If you need to spend a lot of time looking for resources, it's useful to have a large number of individuals with you so that that task can be divided up amongst many eyes. And so instead of you foraging alone, if you're with 100 other individuals, then each of those 100 can take turns, reducing the time you need to look out for predators by 100th, and freeing up more time to look for food that is not as common as it would be in the monsoon. And that could be one reason why you do see mixed species bird flocks form.
Are you able to see the questions in the response sheet? Is it update? I mean, is it refreshing the questions? Because there is one question, endemic species to be considered as specialists from Ram.
I think we talked about that, right?
Okay.
Okay, one sec. Let me just open that again.
Also a question for, Mousumi. What is the significance of, is that discussed?
Hang
Significance,
on.
yeah.
Significance of?
Variance, coefficient of variation.
Oh, right. There was a question on that also, right?
Yes, yes.
That's sorry. So the coefficient of variation is variance relative to the mean, and that's one way of quantifying relative to the mean how much variability is there in that population. So and it's used not just in population ecology, it's used in a variety of fields of science and quantification. uh, it's basically saying if your coefficient of variation, you're just saying if you have a mean of 10 and a variance of 20, then your coefficient of variance is 2. Of 10, you have a variance of 40, then the coefficient of variance is 40 divided by 10, which is 4. And so the second case has a lot more variation associated with the same mean compared to the first. So that's what that means.
Can I explain that context of my question, please?
Oh, yes, yeah. Please go ahead.
Yeah. So what I really had in mind for that coefficient of variation is the fact that coefficient of variation itself is something very well defined in the literature, which is just sigma over mu. Why are we taking variance? Why are we taking sigma square over mu as opposed to just sigma over mu? That was my question.
Right. Why did Mousumi say sigma squared?
Actually, yeah, it's the principle. Krauss's principle actually says it's sigma square over mu, and that was, of course, it's fascinating. It's good. I was just wondering if there is any mathematical reason why they're taking the square of the standard deviation as opposed to just the sigma itself. Because industry, we've used sigma over mu for 40 years for comparing processes, two different processes. So I was just wondering, where did the sigma square come from? So.
It is sigma over mu as far as
Exactly.
Let me just get back to Mousumi, ask her about that, and I can respond either in a subsequent session or put a reply in the document and ask Amrit.
That would be awesome. It was just curious. Yeah. That's all. Yeah, I was just curious.
Sure.
Yeah, I'll send the reply to the discussion forum so that every student can view. Yeah, thank you.
All right. Yeah, thanks, Amrita.
Yeah, I think we have done with the question both in the response sheet and discussion forum, also in the chat. And we have 10 more minutes. If anyone wants to have, to clarify anything, please ask in the chat, or you can unmute and ask. If there are no questions, then we'll wind up the session. Yeah.
Well, thank you all for joining. Of course, I mean, people who need to leave, please feel free. But yeah, thanks again, everyone, for joining. And
Yeah. Yeah. Thank you, Umesh, for joining, and thanks everyone. So I think we'll, if there are any questions, please post on the discussion forum. So after I get the reply from professors, I'll post the answers. Thank you so much. Thank you, everyone.
all right, thanks so much. Bye.
Bye.